myself Dr. NRV. In these videos, we are discussing the different transfer policies for the batch processes. Let's see the different transfer policies. See, there are total 3 transfer policies available for the any batch processes. First one is the zero wait policy, which is denoted by ZW. Second one is the no intermediate storage, and third one is the unlimited intermediate storage. Now let's see what is the zero wait transfer policy. Batch at any stage would be transferred immediately to the next stages. That is called the zero wait policies. Means what? At any stage, material should be immediately transferred to the next stages. There is no holdup of any material in any stages. So it is commonly used when no intermediate storage vessel is available, or when it cannot be held further inside the current vessel. Means there is no intermediate vessel is available and there is no holdup of any material in any stages. So it is called the very restrictive policies. That is a zero wait policy. Second one is the no intermediate storage policy. It is denoted by NIS. So what is NIS? There is a possibility of holding of the material inside the vessel, but there is no intermediate storage. Means in NIS policy, holding of material in any stage for any product is possible, but no intermediate storage. Here there is no storage of intermediate storage vessel is available. This is the second transfer policy, that is NIS. Third one is the unlimited intermediate storage, UIS. Name itself suggests that unlimited intermediate storage vessels are available for at any stage for any products. So this is called the UIS, unlimited intermediate storage. So what is the cycle time for the UIS? CT, cycle time for UIS, maximum of Z is equal to 1 to M, summation of I 1 to N, Ni tau Ij. Now what is tau Ij? We have seen that tau J is the processing time for stage J. Similarly, tau Ij is the processing time of product I for the stage J. J is the stages and I is the product. And Ni, what is Ni? This Ni is the number of batches for product I, and M is the number of stages, and capital N is the number of products. Now let's see the examples for zero wait transfer policy. Consider that there is a two products A and B which requires a stage 3, 1, 2 and 3. For stage A, processing time 6, 4 and 3 are required for the stage 1, 2 and 3 respectively. Similarly for the product B, 3, 2 and 2 processing time is required for the stage 1, 2 and 3 respectively. Now how can we draw the gain chart for this example? Very easy. For the product A is required 6, 4 and 3 processing time. So draw the this is the stage 1, this is the stage 2 and this is the stage 3. So draw the 6 hours horizontal line, then 4 hours horizontal line for stage 2 and 3 hours horizontal line for the stage 3. So we can easily draw the gain chart for the product A. 6 hours, then material is transferred to the stage 2. After 4 hours, material is transferred to the stage 3, and after 3 hours the product A is produced here. Now there is a trick in the product B. Now for the product B, stage 1, 3 is the process time. So if we start the product B from immediately after the 6 hours, we can start the product B. So we can, if we start the product B after 3 hours, there is a 1 hours a gap. If we start the after 3 hours, stage 2 is not free after 3 hours, because stage 3 for product A is a 4 hours of processing time. So after 3 hours, 1 hour is, there is a hold up required for the product B in the stage 1, because stage 2 is not free. Stage 2 having a 4 hours processing time. So stage 2 is free after 4 hours. So there is 1 hours of hold up of material B is required in the stage 1, but in 0-8 policy there is no hold up possible. So we have to start the product B after 1 hours. But similar things happen in the stage 2 also, because stage 2 having a 2 hours processing time, but for the product A, stage 3 having a 3 hours of processing time. So again there is a 1 hour of holding of product B in stage 2. So to avoid this, we have to start the product B after 2 hours. So we can draw the gain chart for the product B. What is the 0-8 policy? We have to, when we complete the any stages, immediately we have to transfer to the material to the next stages. So if we start the product B after 2 hours, 3 hours for stage 2, immediately we transfer the material to the stage 2 product B. Then after 2 hours processing time, and immediately it will transfer to the stage 3, then 2 hours processing time stage 3. So one trick is here, after drawing the gain chart for stage A, we can start the gain to draw the gain chart from stage 3. Draw the 2 hours gain chart here, then come upside stage 2 hours, then come upside stage 3 here. So you can see that there is a 2 hours of gap. So start the to draw the gain chart from bottom, stage 3, then stage 2, and then stage 1. So there is a 2 hours of gap. So we can see that total cycle time required is 6 hours plus this 2 hours gap plus 3 hours. So total 11 hours of cycle time is required for the 0-8 transfer policy. Now we can see the second transfer policy, NIS, no intermediate storage. We have seen that there is a 1 hour of holding is required if we start the product B immediately after 6 hours. So draw the gain chart for the product B immediately after the completion of 6 hours of product A. Draw the gain chart 3 hours, and there is a 1 hour of holding of product B in stage 1. So after 1 hour of holding, material stage 2 is empty. So transfer the material product B into the stage 2. Then 2 hours processing time for the product B in stage 2. Then again 1 hour of holding. Then transfer the material to the stage 3. Then 2 hours of processing time. So this is the gain chart for the product B. So we can see here 6 plus 3 and this 1 hours of holding. So total 10 hours of cycle time for the NIS policy. While in the 0-8 policy, cycle time is 11 hours. So here we have reduced the 1 hours of cycle time by using the NIS policy. We can see the transfer policy, third transfer policy, UIS. Now what is the UIS? Unlimited intermediate storage. So we have shown we have drawn the gain chart for product A 6, 4, 3, and gain chart for the product B 3 for stage 1, and 1 hour of hold. Instead of 1 hour of holding of material B in the stage 1, we can use the intermediate storage vessel and transfer that material into that intermediate vessels. So by transferring the material into the intermediate vessel, our stage 1 becomes empty. So we can start the new batch of product A after the stage completion of 3 hours of product B. So we have reduced the, again here one, we can say that we have saved the 1 hours. So similarly in the stage 2 also we can use one intermediate storage. So after 1 hour of in vessel, the material of product B is transferred to the stage 2. Then 2 hours of processing time, 1 hours hold 1 hour of holding in intermediate storage, then it is transferred to the stage 3. So in this process, two intermediate storage is used. Two intermediate storage vessel is used. So cycle time for the UIS policy is 6 plus 3, 9 hours. For 08 policy, it is 11 hours. For NIS policy, it is 10 hours. And for UIS, it is 9 hours. So we can we can reduce the cycle time by 2 hours. So for UIS, the cycle time required is 9 hours. Now,